Hello, ma'am.
I tell you, focus, will you please start immediately by sharing the screen? Focus now. Please share your screen. Share your screen and please begin. Bala.
Yeah, ma'am. I'll start with my presentation. I'm sharing my screen. Is my screen visible?
Yeah, we can see it.
Yeah, I'll do the presentation. Okay, good evening, everybody. I'm Bala R from Pondicherry Engineering College, Puducherry. Now I'm going to present my idea for this conference, that is the secure and effective authentication for 5G networks using blockchain. This is the agenda for my presentation. Since I'm going to use the blockchain in the 5G authentication process, I'll give a short introduction about blockchain and 5G and followed by the literature survey. So far I did, and then the gaps that I found in the literature survey, and then the objective as a solution for the gaps that I found, followed by the proposed methodology with research and discussion, and finally I'll conclude my presentation with my findings. This is a short introduction about blockchain. Blockchain is a chronologically updated and distributed digital record which is shared among the participants, which is cryptographically protected. We can define the blockchain as a linear chain of blocks where the information is stored in a block, and all the blocks are linked by using the hash functions. And the reasons why the blockchain is becoming famous nowadays is the security, immutability, trust, adaptable, and transparency. This is a general blockchain process. Here, if node A wants a request resource from node B, then a transaction will be created having the request information, and then for a particular duration of time, all the transactions will be bundled together as a block, and then the block will be verified using the consensus process. Once the block is certified, it will be added to the blockchain, and after the whole process is completed, the requested resource will be given to the node B. This is the general blockchain process. And next, I'll give a short introduction about the 5G networks. We all know 5G is the next fifth generation technology for the mobile networks, which is the successor of 4G. This 5G is very famous for its high download speed because it gives almost 10 GB per second. For attaining this high download speed, they are using the millimeter wavelength. So the coverage area of the 5G networks is very short, which is not even 2% of 4G stage. Because of these reasons, the whole geographical area is divided into smaller cells, and these cells are connected to the network using antennas that is located in each cell. Hence, for ensuring the reliable 5G signal, a lot of cell towers and antennas are required, resulting in a frequent authentication process. Because when an user equipment is moving between the cells, every time that is the authentication process going on in the network. This was the literature surveys I made. The first is the blockchain technology, the positive impact on society and industry. Here, the basic concepts of blockchain and then consensus algorithm, mining process, everything got discussed in the first paper. The second is the Bitcoin. We all know blockchain got introduced as a basic concept in Bitcoin, which is a digital currency. And then these two are the survey papers I referred for learning all about the consensus algorithms and then the process involved in the blockchain. Here, since I'm doing an improvement in the consensus algorithm also, I referred specifically few papers for consensus algorithm. This one is the provably secure proof of stake, which is next to proof of work. And then this paper, the research on incentive method for practical Byzantine model. This is regarding the BPFT consensus algorithm. And next, followed by the blockchain literature works, I worked on 5G networks also. Here in the analysis and suggestion on developing 5G, they have explained what is the 5G networks and in the range, what are the difficulties they are facing, and then the authentication protocols. All those informations are gathered from that paper, and then the security authentication scheme of 5G ultra-dense network based on blockchain. This is the paper where they have introduced an idea using blockchain for 5G authentication. But the major drawback here is they focused on implementing the blockchain in 5G authentication process, but it is having a lesser impact with the result. They are giving a minimal transaction rate. These are the gaps that I found in the literature survey. One main thing is there is a need for frequent authentication since there are a lot of 5G cell towers and antennas. That is the first thing. And then the second is, even though a blockchain-based solution was provided, it resulted in a minimal transaction rate, which is less than 1,000 transactions per second. So I was motivated to use the blockchain features, how effectively I can use the blockchain features for the betterment of this authentication process of 5G networks. The objective of the proposed idea is to maintain the anonymity of the user equipment details in the authentication process, because the user details are shared in the network for the authentication. So we have to maintain the anonymity, and then reducing the authentication frequency when user equipment moves between the access points, and then an optimizing in consensus algorithm where the transaction rate is improved. This is the main principle behind my proposed idea. The main idea of my proposed is whenever a user equipment moves between the cells, every time the authentication process is happening. So what I did is, whatever the authentication process that is happening, I stored the result of the authentication. We are validating the access points. We will store what are the valid access points. Just we will store the authentication result in the blockchain. So again, whenever the authentication is getting repeated, we can refer the blockchain. If the authentication is already happened and the access point already valid, then we can directly provide the service instead of going through the whole process of authentication. So here I'll explain the principle. When a user equipment is requesting for a service, a one-time authentication process happens. Here, access point request for an authentication request, and then it will request for an access point ID. Once the access point ID is generated, a block is created with the access point and user equipment details, and the consensus starts. Once the consensus is succeeded, then that access point is authenticated. It is given a valid token, and then it is added to the blockchain, and finally the requested service is given to the user equipment. This is for the first time. Again, when a user equipment moves again, if the result is already available, it will be directly provided with the services. This is the process flow that is involved in the proposed methodology. One is the direct flow, where the results are already exist. The requested service is directly provided. One is the one-time authentication process. For the first time, the access point is authenticated. Here we have made the improvement in two levels. One level is we are speeding up the process, like without repeating all the process of authentication. We are speeding up the process by reusing the result that is getting stored in the blockchain. That is the one level. And then the second level is we have given optimized consensus algorithm. We have reduced a sequence of steps involved in the consensus algorithm so that the time taken for the consensus process is also reduced in a secure manner. These are the two levels of improvements that we have provided. This is the process involved in the one-time authentication process. First, for a particular duration of time, here we have taken as a 10 minutes. For a particular 10 minutes, we will be collecting all the user equipment and access point requests that was registered in the system, and all the requests will be sent for verification, and the verification will be done by the set of existing nodes that is available in the blockchain networks. And once all the requests are verified, and the block will be created. Here in the block creation process, we are using the hash function and we are combining all the transactions and we are creating a Merkle root, and with that Merkle root we are creating a block. Once the block is created, it will be sent to the consensus process. Here in our proposed consensus process, we are having the 4 steps: propose, pre-vote, pre-commit and commit. Once all the steps are executed, finally we will get whether the block is certified or not. Once the block is certified, then that block will be added to the blockchain. This is the consensus algorithm we have used in the proposed system. Here we have explained, like in initialization, what are the things happening, and then in every step, what is the process going on. Here in the proposed step, we are validating the access point. We are doing the authentication of access point, and we are propagating the authentication result through all the nodes. Till now, I explained the algorithms and the proposed methodologies. Here, yeah.
Last 5 minutes, please.
Yeah, sure. This is evaluation metrics which are used to evaluate the proposed system with the existing. The first thing is the authentication rate, which is the number of authentication result that is added to the blockchain per second. This is calculated based on the block processing time and the number of requests occupied in the block. The equation number 1 is used to calculate the authentication rate. The second is the processed authentication count. This is for every duration of 5 minutes, we are calculating how much authentication request is coming in and how much are getting processed newly and how much are reusing the result. Based on this, we are getting the values of processed authentication count. And processing time. This is the whole time it is taking to process the request from UE, user equipment, till the service is delivered to the user equipment, the whole processing time. And the experimental setup is, we have implemented the proposed work in Hyperledger Fabric. It is the framework for blockchain technology, and it got implemented in Millennium system with 2 environments. One is 25 access point and another is 50 access point. These are the results. First, the authentication rate is compared. Here, the red color indicates the proposed work and blue color indicates the existing work. And the first graph is for 25 access point and second is for 50 access point. It clearly shows, it is showing an improvement by improving a percentage of 56.79 when compared with. This is the processed authentication count. Here we are calculating it for every 5 minutes. So we can see a decrease in the processed authentication count, resulting in an improved system performance, because we are reusing the results. So re-executing of authentication is getting reduced. This is the processing time. You can see the proposed system is drastically reduced by reusing the existing results. So it is showing an improvement by 36.19%. And then conclusion. Actually, I explained the limitations of literature survey and then proposed an secure and effective authentication scheme for FIDO network using blockchain. The proposed strategies were implemented in Hyperledger and results were evaluated using all those 3 evaluation metrics. And results obtained also, it clearly confirms that the proposed methodologies significantly it outperforms when compared with existing. These are the references I used. Then thank you.
The presentation. If you can put on your camera, would be better.
Yeah.
Here we have our session chair.
Okay. Yeah, very sorry.
Hello. Yes, Bala.
Yeah, sir.
Just give me what are the roles in the current pricing authentication system, and why we need to go for the migration.
Sir, actually, it's not clear, sir. It's breaking, sir. Hello, sir.
Yes.
Ma'am, it's breaking, ma'am. I was not able to hear the question clearly.
We can hear you, Bala. Please go ahead.
Hello, ma'am. Actually, the question I did not get. It was not clear.
What are the loopholes in the current system?
Okay.
One Yeah, the one we have discussed, no, presented, very well you have presented with all the
Okay.
algorithms and the implementation details with the graphical
Okay.
analysis. We appreciate that.
Okay.
But have you compared your system with any other existing system and what are the loopholes in it?
Actually, ma'am, we for the algorithm, we compared with BPFT. Whatever improvement we have made, the proposed is ours UEAP BPFT, and then we compared with BPFT, and then the processing count we compared with AKA. This is existing for 4G. With that we compared this processing time and then PAC, processing authentication count. Those two metrics we compared with AKA.
Okay, my dear. Thank you for
Yeah,
presenting.
thank you. Yeah, thank you.
Let's stop sharing your screen, my dear. Thank you, Bala. Good to see you. Shubham and Mithun?
Yes, ma'am. Shubham.
Yeah, Shubham.
Yes, ma'am, Mithun.
Right. Shubham, you have got a right of sharing of a screen.
Sure, ma'am.
Please go ahead.
Sure, ma'am. Ma'am, it is visible.
Visible, you have 10 minutes for presentation, 5 minutes for question and answer. No, please.
Sure, ma'am.
Thank
Sure,
you.
ma'am. Good afternoon, one and all present here. Myself, Shubham Chakravarti, presenting on our paper titled Transparency in Carbon Credit by Automatic Data Management Using Blockchain. Honored to present in IEEE ICBDS 2022. Our paper ID is 50. These are content which will be covered through this presentation. Let's get started with introduction. Economic growth is topmost priority for countries going forward. However, to achieve economic growth, we should consider the usage of natural resources and also should keep an eye of human venturism, such as combustion, transportation, and waste generation. In order to effectively limit the emission of greenhouse gases, the cost of using carbon as energy source need to high enough to motivate the necessary changes to need in economic behavior. A high carbon prices raise the cost of products according to the carbon content. The raising the price of carbon achieves the awareness in consumers. So the services are carbon intensive, which should be more used sparingly. These are some surveys done by Genius J, presented an example where blockchain is used to interact with machines and establish a electricity market within respect to chemical industry. It is contributed in consensus in blockchain implementation, a comprehensive hierarchical blockchain system of carbon emission trading utilizing blockchain of things and smart contract by Alias Wadi proposed an idea of providing a 3-level of framework consisting of 2 blockchain. It is also used a smart contract extensively to provide an automatic mechanism and management system which is trustworthy. Ivan Tonyev in their work explained the advantage of existing system that once data is received by blockchain system, there is no possibility to change it. Our problem definition. Carbon credit calculation at the present depends on a manual data gathering and disclosure. The vetting process is also manual with a lack of transparency, making it non-trustworthy. So it is a way forward bringing a transparency in carbon credit, thus bringing a practical innovation in sustainability. So some of our important objectives are here we have set up the network where a multiple organization, industry partners, and vetting agency can join, perform their data gathering transactions. The application should be capable of calculating carbon credit in a parameterized way and configure manner. The platform should be able to integrate a core system across the various entities for building blockchain ecosystem. Vetting agency and organization should be able to view a carbon transaction. The solution should maintain a privacy in the system with a proper access control mechanism. So in our existing system here, we saw there currently the data is gathered in a manual way and user fill up their emission data. The organization emission data can be checked and verified only by allotted government officials. Right now, the calculation of carbon credit is done manually. The organization needs to regularly check on their data to plan future emissions. So here is our proposed system. Here in proposed system, we have two interface, organization interface and vetting interface. After successful signing in, it will connect to our blockchain network. In organization interface, we can collect the concentration of gases automatically through the sensors, which are placed at the major hotspot in organization. After collecting the concentration of these gases, we can calculate the carbon credit based on the gathered data and put it in our blockchain network. Here, we have given a wallet facility to organization where they can see their carbon details, carbon credit details like allotted credit, credit used, and available credit. In coming to vetting agency, they can see the transaction details of specific organization using their unique 5-character ID. So in our project, we are taking emission data of 6 major gases. They are responsible, according to which we get the CO2 equivalent of all these gases and multiply it with global warming potentials. So the main key element of our applications, as we know, blockchain, it is a shared immutable way of storing transaction that can provide transparency of data by sharing data to all nodes in the network. Interface. In our system, we have made separate interfaces for both organization vetting agency, as I mentioned. In organization, they have specified their sector while registering. Every organization has a unique ID in which the vetters to get information about their secretion of specific organization. Whenever an organization logged in their successful, they are connected to the blockchain network. Sensors. For detecting CO2 gases, we are using MHZ14A CO2 sensors with a measuring range 0 to 5000 ppm with accuracy of plus minus 50 ppm. Data management and calculations. This data is coming from the sensor, is stored and pushed into the blockchain ledger on the daily basis. These sensors are fixed in all major hotspots where the GFG gases is produced, stored in a data from all the sensor in the one place. Similarly, concentration of all other major gases is calculated. Here we have a snippet where we can see how the other nodes are configured with equivalent. They are taken in grams and are converted in kgs.
Sorry to interrupt you.
Sure, ma'am.
Last 5 minutes wait for the presentation. Yeah.
Sure, ma'am. Sure, ma'am. So the results. The organization emission data is loaded in our blockchain network automatically with help of sensors, hence removing all kind of manual interventions, providing transparency. Vetting agency can verify organization transaction details by using their unique 5-character ID. So we have here we develop a building this model. We come up the conclusion that with a growing consensus among the nation to limit industrial GHG population together, positive industrial growth emission curtain appears to be a chief area of business attraction today. Here we have tried to create a blockchain platform which will allow high emitting organizations to detect their carbon footprints and mingle their quotas. Thus, setup spots of CO2 sensors have been made in such a way that is should be follow a law made by the government organization to achieve the purpose of giving accurate and endeavor values of liberated CO2 gases. Our future scope. In a future, we will try to add all types of sensors which will provide accurate data of emissions from particular sectors in a organization. And all these sensors will be automatically connected to our blockchain technology, which will help to store all time data in database of our model. These stored data can help organization to get idea about which sectors is emitting more gases and what action should we take on it. This is our references. Thank you.
Thank you, Shubham, for the presentation. We have our session chair here, and I've got a couple of questions for you.
Sure.
Sure, what are the limitations of your system?
So there were some limitation in our systems, like we use some sensors in some area. So like in our idea, like someone can tamper with the sensors manually. So if they tamper with the sensors, they can tamper with the data. So here we are using hardware oracle, sir. So these oracles are application required to get information and reading from physical world, sir. So this data will exist only the targeted object, which will measurement will be done locally and often in real time. The data is private, accurate, and information cannot be arrested neither by public Fed or by any local officials.
Okay, okay, sure.
Yes, sir.
Shubham, it was a wonderful presentation indeed. Thank you so much.
Thank you, ma'am. Thank you.
Please stop your screen sharing, madam.
Sure, ma'am.
Presentation on the behalf of students I am going to present.
Now I would request Dr. Amar to please take over for the presentation. The title of the presentation of his paper is Decentralized Voting System Using Blockchain.
It will explain. Zoom we can close.
Mr. Anand, are you here? Mr. Anand?
Ma'am, this is Mithun. I'm in for Mr. Anand.
Oh, okay. Okay.
Okay, if Anand is there.
Okay. Anand and group, that is Mithun, and just
Yeah.
give you the rights to the presentation.
Okay.
I'm making you co-host. Let's start with your screen sharing.
Is my screen visible, ma'am? Hello.
Yeah, that's visible.
Thank you.
Please give the time.
Please respect the time here. Mithun, 10 minutes for you for the presentation, followed by 5 minutes for question and answer.
Thank you so much, ma'am.
I request you to go to your contribution. What is your role in the project? And that will help us to understand. Because by the end of the day, everyone is enlightened on what a blockchain and security in it. I request you to go to your contribution directly. Would be really helpful to contribute. Yeah, thank you.
Thank you. So, my project is secure e-market reduction for advertisement slots using blockchain. So, with the myself, Shaktivel, and Mr. Anand, Dr. Anand, were the authors for this project. So, firstly, I want to split my presentation into 3 things. Why do I want an e-market auction? What is this application that I'm going to give, and how I'm going to bring blockchain into picture here? Okay. I think, ma'am, that was your question. How I'm using blockchain here. So that is a part of my presentation. So I will explain it together. So why we got motivated to make this as a project. So firstly, there is nobody to bring this in a centralized manner in the sense, nobody to govern the advertisement slots. So each advertisement slots are being sold to only highest payers or only to the known companies. So take an example, Star Groups gives their products, their advertisement slots only to the known persons, not to the lower or Indian brands. So I want to cultivate a society where even the lowest and cheapest brands can show their products on screen. So that's the major motivation. And then when I went on and checked with other projects, something like similar to this, I found there is no other project like this, but except for online advertisements in the sense like advertisements in social media platforms. So the target of our venture is to make this a kind of a e-market where we can sell advertisements through auctions. Sell advertisements in the sense, sell the advertisement slots for a channel. Okay, so we are going to sell those slots either in an e-market format or inside the e-market itself. We will have an option to sell those through auctions or flash sales and many other options down there. Okay, so the same with the abstract. So what have I told? So we don't have any government authority or any governing structure to formulate this thing. So this project, we want to present it to TRAI, that's Telecom Regulatory Authority of India. So at least then we will get our business, I mean our lower small scale industry to cope up with the other bigger brands. So related works. So here, let me first clearly show you. I'm going to show about 2 papers. Okay. I'm going to show about 2 papers. One is our friend, one is our enemy. But that enemy can become our friend. So this is the enemy, the auto bidding nature. So can you see my mouse pointing? Yeah. So auto bidding. In an auction, when there is a system that can automatically bid, the auction will elapse its time. So that's the reason the other industries like the Googles or the Facebooks in their online auctions, they don't give English auction type of methodology. They use different auctions like Vickery Clark grooves and other setups where the auction ends in a specific time. But that specific time is not fair because one person in the last minute or the last second can win the auction with just one click. That will not make it fair for the customer. So we want to bring it into English system in the sense it will take time unless and until you finish the last bidder wins the auction. So that's where the auto bidding has to be managed. And this is my main base paper, the Google's auction for radio and TV ads. They made it very long ago. The problem that they faced is scheduling in that 5 minutes. Assume there is a 1 hour slot, and in a 1 hour slot there will be an advertisement slot for 5 minutes in 3 different ways. Okay, so that 5 minutes has to be broken down, and that has to be scheduled one by one. And in that, people will watch only the first ad and maybe just before the program start the last couple of ads. So that ads has to have more value than the previous ones. So we make a solution by giving that we define the slots. We tell that this is the first slot, and we define that this is the last slot. This has to be a 20-second ad. This has to be a 30-second ad. So we define it clearly, and only then we are going and giving that to that advertisement. Okay. So in the solution, so till now I was explaining about my application. So let me just take a little more about my application and then say how I'm going to bring blockchain into picture. See, this blockchain is totally going to be my infrastructure, not my application that I'm going to show. Okay. So here we have 3 stakeholders. Number 1, that's me, that's the venture, that's the admin who is going to control everything. Then the advertiser and the broadcasting firm. Advertiser is like, assume a company like any company that who wants to give their advertisement to be shown in TV. And the broadcasting firm is the channel. So these are the 3 players. This is the request and response flow that I want to show. Here in the database, we will have a major classification for bringing the blockchain into picture. Okay, so a request will come into a home page and login page and move to the web servers that we have. Web servers will just give the display of contents, and then it will go to the app server as generally. Then from the app server, it will serve like you'll be able to toggle around with what kind of ads you want to choose, what is the timing you want to choose. All the switch buttons will be there. So from there you'll be getting connected to the database. So this is how a request and response flow will happen in a website, in our website, sorry. So this is how the more clearer picture. So once a user logins, it will directly interact with the database. When the user directly interacts with the database, that is where the blockchain comes into picture, because we have to make the user come into come inside the blocks. So we will be having a unique ID creation method where we are going to secure his credentials with keys and then save it there. But we must.
Let me interrupt you. This last 5 minutes we took a presentation, yeah?
Okay, ma'am. Thank you so much. So that's where the user can access his things. And then all the 3 users will be kept in the database: the advertiser, the broadcaster, and the admin. So once they get into it, the first this scenario, let's make it for the advertiser. So once he gets into, he will go to the home page. From there, he will be able to access these two things, flash sale and the auction. So whichever he chooses, he can choose, and the payment gateway is going to be a blockchain based currency, so that it is more secured and it is tracked always. And then he's going to get his product sold and kept it inside the database, that is again going to be encrypted and kept inside. Why we are doing this? What is the need for just shopping cart things to be saved in such a big database fashion? In the sense, the buyers are going to be bigger companies. uh, they don't want to share their strategies of buying advertisements. So that is the reason we want blockchain to come into picture. So this is the modules that I'm gonna bring, that I made for my website, for this website. So authentication module, that's gonna do that. User verification is going to be like a KFC process, sorry, KYC process. I'm extremely sorry here. KYC process, where we get to know about the customer, and then the site flow is being written here. I will show you the algorithm that I'm using for the site flow. That's the same as the functional block diagram, and the payment methodology and the admin page to control. So this is how this is the same as I explained for the functional block diagram. That has been written as an algorithm. I have written this algorithm because there is no other predefined algorithms for this methodology. So that is the reason I don't bring any other algorithm into picture. Rather, I use mine. So this is another major limitation, because there can be many problems with predefined algorithms. Sorry, user-defined algorithms. So here, this is where I'm gonna explain to you about how I'm gonna schedule my advertisement. So if there is a 5-minute advertisement, I'm gonna break down into things, and those things are gonna come into like first major part will be for a higher price, and the last part is going to be for a higher price, and middle is a cooling spot. So that is how this setup is planned. So now let me explain about how I'm gonna bring the blockchain into picture. Okay, so you understood about my application. So this application is to be hosted on cloud. Once this application is hosted on cloud, it will regularly like this. It will normally have this part on cloud where all the servers are running, and in a different setup we will have a cloud for decentralized methodology, where we save all the database contents in different spots, and then the data comes and goes. Okay, once it is asked and kept inside, we can't take it out. We can't take it out in the sense, it is not an easy process. It is going to take another set of extra reading. So what I'm going to do here is bring a relational database into picture. So I'm gonna have a relational database for normal usage things, and only for the transactional data I'm gonna save it there, save it on my blocks. And rest of the things like the order history, everything is directly going to be deleted, and only if the user wishes, he can directly go through the database to the he will be coming to the relational database, and then he will be asking for his contents. If he wants to view his history, then from here through the keys, he will be going and getting his data from the blockchain, and only then he can see his history of buying the products. So that's the major shift from the normal application that we have. So this is an example of my output. So this is where the user can come in and log in. This is where he will be able to bid. The first screen is where he will be able to bid. Once the auctions are won, he can directly pay and get the products into his name. So this is for time being, I made it like a normal payment methodology where I can use it with the test mode. So futuristic. way. Okay. So this application has to be used everywhere, because only then at least we need a centralized technology. Centralized technology in the sense, I mean, a governing body who can govern the to and fro of the advertisements that are bought and sold. Only then we can avoid corruption, we can avoid many other things that happens in TV industry, broadcasting industry. So then I wanted to tell you about this. This is what I'm going to use for my infrastructure, decentralized cloud storage using blockchain. That is where I got the idea of doing it. Thank you.
Thank you, Anand. I mean, on behalf of Anand, you have completed. Indeed, it was a great presentation, and on behalf of conference team, I really would like to thank you.
Thank you so much, ma'am.
Our next presenter for the day is Dr. Amar, and herewith I request you to please present yourself. And you can stop sharing, Maria.
I have to download it. Otherwise, I have this presentation.
Vipul, can you stop sharing?
Let me check this.
Yes, ma'am. I'm not used to
Close your
Zoom, so I'm
presentation.
trying my best. Did my screen leave, sir?
Please close the screen.
Yes, I'm trying. Is it clear now, sir?
Yes.
Thank you so much.
I'll be presenting you on the behalf of students. Because I am the co-author for this paper. Thank you for giving the opportunity. So the title of the paper is Decentralized Voting System Using Blockchain. So why decentralized voting system using blockchain? Because for security reason, right? So in India there is a democracy. So there can be a possibility that if the user votes through electronic media, so there is a possibility of tampering. So that is why this blockchain can be used for security reason, right? So this system can be used for any organization for e-voting purpose. So the problem statement is designing decentralized voting system to address the issue of maintaining anonymity of users or voters on a public blockchain network and achieving transparency, security, safety as compared to the existing models. So anonymity of the voters can be maintained through the blockchain model. due to its properties. So due to the hashing mechanism included in the blockchain. So the proposed framework is divided into 3 phases, that is pre-election, election, and post-election. Right. So here in the diagram 1, the election structure will be defined. The smart contract is created between the user, that is voters, and the administrator, right? Because if you see administrator and voters, so they are untrusty environment. There is an untrusty environment actually, right? That is why we are using blockchain, and with the help of smart contract creation, it's possible, right? Then ballots are also part of this blockchain. Then voting window, notifying election officials, then results are also important. So this is the system architecture where the blockchain is playing important role in this. Because here user can be at different location, and this where the voters which are stored will be at different location. Blockchain can play important role in this. So actually this is a web application which involves the web interface through which the voters can view the voting. There is central server, smart contract, organization servers. So this is basically use case diagram where the different users you can see the organizer, then voter, then blockchain, and server. For example, the organizer can be any society, or it can be a government of India, or it can be a Gram Panchayat election, right? And voters are normal users, right? So there are various mechanisms to organizers can authenticate, create election. For example, government of India approve the election, right? Then voters can register for voting, then approve the ballot, right, using MetaMask. Then voting is possible. Through blockchain, we can track the election deployments. That is possible by using blockchain. We can track voting statistics using blockchain. The server credentials can be verified. The election factory can be deployed. It can check eligible voters also. So basically, why this is happened due to property of blockchain, that is immutability, decentralization, then public key authentication mechanism which included. So here I want to know who is the authenticated voters. So that is possible because of using digital signature in blockchain, right? So one of the disadvantages in the blockchain that 51% of the nodes, right, are managed. So obviously it is creating the problem, right? So that is the disadvantages by this blockchain, right? Here there can be disadvantages like if the servers are managed, right? Voters are voting their ballot, right? So there can be a problem. So this can be a consensus problem. So actually, these are the software requirements, database requirements, hardware requirements. There was a demo and conclusion. So due to the properties of blockchain, so it's voting possible. Any other questions? I can answer.
50% लोकांनी जर तुमचं वोट अलाउ नाही केलं तर that will be considered or not considered? Because in a blockchain we consider at least 50% should be agree.
Right.
म्हणजे 50 ते 51%.
Oh, yeah.
Full drawback of
There is a problem because if the 51% voters are managed, so we cannot do anything, right?
And 50% is a major threshold.
That is why there is a concept of digital signature. So we come to know who is voted actually, right? In the natural scenario also, this is possible. 51% can be managed easy. So this is one of the problem currently faced by the blockchain. Thank you very much. Any question?
Thank you, sir.
Thank you very much.
So with this, I now would like to conclude the session 2 for the day for the International Conference on Blockchain and Distributed System Security 2022. I would like to thank you for giving me an opportunity to coordinate the session, that is session 1 and session 2 for today, that is 17th of September. And I really would like to extend my sincere thanks to the complete committee of the conference and my best wishes. And thank you so much. We are winding it up here. I say that session is concluded for the day. Thank you.
Thank you for giving valuable